Alright, third time's the charm. Let's finish that motherboard. So last week we started on one of the most complex pieces in your computer build, and that's the motherboard. And this week we're going to wrap it up. Not only will we look at the graphics card, expansion slots, and drives, we'll also look at the other chips on your board. Think of it as extra credit. Besides requiring certain components to be added to function, motherboards also include a number of expansion slots in the way of PCI or peripheral component interface slots. These versatile little guys have been responsible for handling anything from graphics, to network connections, to sound cards, to FireWire, USB, and so on. If you plan on adding any extra components that have a card in the title, then it goes here. Oddly enough, PCI, now in the Express flavor, has come full circle in a lot of ways. Early graphics cards utilize the standard PCI slots and actually let you run them in tandem by just dropping another one in. We'll miss you, Voodoo. While AGP may have killed the PCI video card, it was a necessary step in faster throughput. If you look into your old computer, or maybe even your current build, you'll see an irregularly spaced brown socket. This is your accelerated graphics port, or AGP. Think of this as your black dynamite of 3D acceleration. Classic, badass, and, well, past its prime. PCI has come back to claim its graphics card throne by slapping on an E at the end, timesing by 16 power, and going all 2.0 on its ass. That's right, PCI has again overtaken AGP, but at the cost of still needing to be very specialized to do it. Now, it's true that you can put any PCIe device in the on steroids version and still have it function, but that's like sending a coma patient to Disneyland. For all intents and purposes, a PCIe 2.0 by 16 slots are for graphics cards. You'll want as many of them as you want video cards, and they are backwards compatible. An 8-speed card will work in a 16-speed slot, but not the other way around. So get the 16-speed and downgrade the video card if you want to save money. Our motherboard has two PCIe 2 16-speed slots, though we're only putting in one graphics card for now. This is so that we can dual card later on if we decide to upgrade. Important note, if you are choosing to go the multiple card route now or down the line, make sure that your Mobo supports SLI for NVIDIA cards or Crossfire if you choose ATI. There are those that support both, but make sure that you check. Ours, for example, is an ATI Crossfire only. So what do you do with those piddly leftover PCI 1-speed slots? Well, that's up to you. You can load those with network or sound cards, but both of those can be sufficiently integrated into the motherboard itself. Our motherboard, for example, has both an onboard Ethernet connection and integrated sound. If you do decide to go the non-integrated route, just make sure that you have enough PCI 1-speed slots to cover the bases. Alright, home stretch. You ready for this? The last main portion we need to touch on is how drives such as your DVD and hard drives connect to your system. If you've been brave enough to peek inside a PC before now, you've probably seen one of those giant flat gray cables snaking its way between all of your drives. This parallel advanced technology attachment, or PATA cable, was the fugly standard for many years to connect all of your drives together. Also referred to as an IDE cable, it has multiple plugs along its length to jump from drive to drive and connect to your motherboard. This is since given away to the newer serial ATA connectors, but it's worth noting that if you're salvaging old drives, you will have to make use of this old boy. If the plug on the back is a long, thin block, then it's a PATA. If it looks like an L, then it's a SATA. Odds of finding a board without a PATA plug is slim, but making sure it has enough SATA slots, on the other hand, is what you need to keep in mind. The now standard SATA connections itself has a few flavors, having to do with the top speeds it can handle. A SATA 1.5 gigabit a second, a SATA 3 gigabit a second, and a SATA 6 gigabit a second at 150, 300, and 600 megabytes a second, respectively. Awesome! Faster is better, right? Well, of course. But in this case, it may be wasted too. Currently, the fastest conventional hard drives can barely max out the SATA 1.5 bandwidth, with the more expensive solid-state drives being able to fully maximize the SATA 3s. It's not until you start hitting the high-end flash drives that you can start breaking into the SATA 6s, though that's not to say we won't get there. For our own purposes, the SATA 3 gigabit a second will be more than enough to handle our conventional hard drives, as well as provide a little upgrade flexibility down the line if we want to add solid-state drives later on. Our motherboard comes with 7 of them, so that should be more than enough to connect our 1 hard drive and 1 optical drive, as well as another 5 hard drives. You know, if we want them. Now, what would we ever do with that many hard drives, I hear you ask? Well, this is where raiding comes in, and no, I don't mean you and 24 of your closest strangers. This may be something we cover in a future episode, but just for your hungry brains, RAID stands for Redundant Array of Inexpensive Disks. Ha! I love engineers. RAIDs come in different levels and uses, but in essence, it allows you to install multiple hard drives that work together as one. This can, on a most basic level, add speed, but as you move up the chain, add safety and stability to your data. I only mention this because it is a feature we decided to include, but only for potential future improvements. Again, this keeps with the theme of knowing that we're going to be upgrading in the future. If you're confused, just close your eyes, take a few deep breaths. It was all a bad dream. Okay. I know that was a lot, and to be honest, all the variables we've just discussed should alone be enough to help guide you through selecting the right motherboard for you. As you research, however, you may come across a few more terms that you may be curious about. These will likely not skew your decision by much, but they're worth mentioning so that you're not caught off guard. The first up's the frontside bus, or FSB. Everything called bus in your computer is all about transporting data around your machine. The FSB is the vehicle to and from your CPU. It's effectively the bandwidth that limits how much info can pass back and forth, so the bigger the number, the better here. However, this is going away as processors, especially Intel, are starting to handle this themselves, so maybe it's more of a front-side minivan these days? Lastly, we have the north and south bridges. These guys are the air traffic controllers of your motherboard. They are chips that each specialize in handling specific components of the board, the north being the high-speed items, like your CPU, GPU, and RAM, and the south getting just about everything else, drives, audio, power, PCI. You know, for the average builder though, the specific chip controlling each of these won't really be an important variable in your decision. So, we're done, believe it or not. If you survive this, then congratulations. You will have no trouble getting through the rest of the build. If there were some parts that were a little less than clear or confusing, feedback in the comments and we'll do our best to clarify. Also, if you're an old pro, we want to hear from you too. Your input is just as valuable to other knowledge seekers as well as keeping this series on track. Let's all reach out a hand to our PC brethren and keep this tradition alive. Now I understand we give you a lot of information, so for some of you the voice treatment can be a little grating. So we'll be doing the next episode entirely in a normal voice, so let me know what you guys think in the comments, and from here on out, smooth sailing.